In this problem, we're going to be solving a radical equation using the graphing method on your calculator. We're given the function f of x equals the square root of 4 plus 2x, and our job is to find the input x, which makes the output f of x equals to negative 8. So since the output value that's desired is negative 8, these two things are equal, and I can make a substitution where I see the notation f of x. Since it's equal to negative 8, I can make a substitution and put negative 8 here. So if I did that, it would look very similar to this, except for, I guess if I literally substituted f of x with negative 8, then negative 8 would be on the left-hand side of the equation, not the right, but it's still an equivalent equation. We're basically solving this equation right here. So written in this format, this may look more familiar to you than written in this format, but basically when you need to solve an equation like this on your graphing calculator, you can take one side of the equation, put it in y1, the other side and put it in y2. It doesn't matter which side you put into y1 or y2. The order is not important as long as you put one side of the equation in y1, one side in y2. So when you turn your calculator on, you start on the home screen. So if my calculator was off and you just pressed on, the default is to start on the home screen. You press y equals to type in an equation. Now I've jumped the gun a little bit. The directions actually say that we're going to do this using our graphing calculator, and they give us a suggested window here. That's going to help a lot. And then when we're done with that, we're going to follow the steps below to show the intersection graph on the computer. So the idea is we're going to use the technology to do it for us, but we're going to emulate doing it by hand over here once we get the information that we need. So I said that we could type it in any order, so let's just type the negative 8 in first. Make sure you use the negative key, not the subtract. We're not subtracting anything. We just have the number negative 8. That's going to produce a horizontal line through negative 8. I'm going to down arrow over, and to type in the square root, I need to use the second key because the square root is above the button, meaning it's the second function of the button. So I'm going to press second, and then this key here gives me a square root. And then I'm going to type in 4 plus 2x, and this is the easiest button to get an x on the calculator is this guy right here. And I'm going to put a right parenthesis to tell the calculator that that the 4 plus 2x is in parentheses, meaning that the entire expression there is under the radical. So before I graph it, I want to make sure I'm in a good window. So I'm going to press window, and you can just type over whatever window you have with these values here. So the suggested window has an x minimum of negative 4. So I'm on x min. I'm just going to type in negative 4. It types over the old x min. And that is to make it so that the furthest to the left that we'll see is negative 4. I'm going to down arrow. We need to see as far as 32 to the right. And we might not need to see that quite that far, but a lot of times we like to see a little bit further to the right of what we're looking for, which in this case is the intersection of two graphs. I'm going to down arrow to the y min and y max, but it doesn't look like I need to change it because the suggested values for the min and max on the y is negative 10 to 10, and we already have that. So now it's time to graph, and we should be getting that horizontal line through negative 8, and then we should be getting the graph of the radical function. If you know something about square root functions, they typically start on the x-axis and either grow to the right or look exactly like this, except they go to the left. So it looks to me like these two graphs are never going to intersect, and you'd have to just know something about horizontal lines. They do this forever, and the radicals will do this forever, just keep increasing forever, meaning it's not a matter of changing my window to see that maybe they intersect off to the right or something. These graphs are never going to intersect. And what that means is there's no solution to this equation over here, meaning there's no x value in the world that you could plug in to get this expression to come out to be negative 8. So the directions say when that happens, if the point of intersection does not exist, enter DNE as the point of intersection. So this is a special case, and that's why I made a separate video for this problem. Because there's no intersection. So I'm going to click down here and really type in capital D N E. I don't know if it's case sensitive, but I'll play along. So that's the answer for the first question. There is no point of intersection. Therefore, there's no solution to the equation. But we need to emulate the graphing by following the steps here. So we've done step 1. We wrote the point of intersection as an ordered pair. Well, actually we didn't, because if the point of intersection does not exist, we had to enter D and E. Now we need to use the line tool to draw the horizontal line y equals negative 8. Pretty easy to do. Scroll down below the graph, and you should see this line tool. Click on it to select it. To graph y equals -8, we're trying to emulate this blue line down here. So pick any point that would lie on the horizontal line through -8. Click and hold the mouse button down. Move either left or right till you get a horizontal line. Let go, and you're done with that part. Part 3 says use the square root tool to draw the radical function. To draw this function, first plot the point furthest to the left. And we've made these equations easy enough that our intent is not for you to have to do algebra to find that. Simply just to assume that the values come out nice whole numbers. So it looks like the point farther to the left is -2, 0, and then it also says followed by plotting one more point after that. So you could do some arithmetic and just plug in a random x value, or if you want on the calculator, since we've done all the work to get a graph, you could press trace, and since I'm not on the square root function, the cursor's down here, I could up arrow, and I could just pick a point. So one other point would be roughly 14, 5.65, or if you were looking for a nicer one, you could start just guessing and hoping to get one that works out nice by, you could literally just start typing in numbers like, if 14 doesn't work, you could try 15, enter, and that doesn't come out nice either, so you could fish around. But I think 16 comes out nice, but I don't think you'd have to actually do that. I think you could just type in any old value. And maybe picking one farthest to the right might be best. So I might type in 30 and press enter. And all the calculator's doing is replacing x with 30. And you could almost do it in your head. 2 times 30 is 60. 60 plus 4 is 64. Square root of 64 gives you 8. So the idea is now I can click down here on the radical graph here. What does he call this? He calls this the square root tool. So calling this the square root tool, you'd click on that, and then first plotting a point to the left, that was -2, 0. Point at it, click and hold down the mouse key. And then the second point that I chose, I think it's probably best to go way to the right, and you might get a little more accuracy, is 30, 8. I probably would stay away from plotting a point really close over here, as it wouldn't be very accurate. So I don't think you have to find one that lies right on the coordinate grid here. I think you could get one that's close and it would still work. So basically step 3 is done now, and step 4 we don't need to do it because it uses the point tool, which is this guy. I'll click on it to plot the point of intersection if it exists, but it doesn't exist. We didn't have a point of intersection. So we're basically done with the problem now.